Hello everyone, welcome back to Spectrum classes. In this video, we are going to perform a lab activity related to the determination of molecular weight of a volatile liquid, which is determined by Duma's method. So first, I am just going to brief about the procedure of the experiment. So first, we are going to take a flask and we are going to weigh this flask in the empty form. Now we are going to add 5 ml of the sample to this flask and then we are going to heat it on the water bath until all the solution get vaporized. In this manner, we are going to have this kind of situation when all the solvent get vaporized. These vapors are considered as ideal gas, right? And then we are going to cool down these vapors and we will get the condensate of these vapors get condensate and we get this kind of situation. This solution is less than this because this is just equal to the weight of the vapors. Now weigh this flask along with this condensate and then calculate the weight of the vapors by subtracting W2 minus W1. W2 is this, W1 is this. In this manner, we are going to get this weight of vapors. Since we consider these vapors as an ideal gas, therefore we are just going to apply ideal gas equation, which is PV is equal to nRT. Now we need to consider all the pressure, volume, number of moles and temperature for these vapors. For that purpose, we are going to measure the pressure of these vapors, which is very difficult. So to make it easy, we just make a hole in the foil which we are going to wrap about this neck, and so that the vapor pressure is equilibrate with the atmospheric pressure. And in this manner, the pressure of these vapors is equal to the pressure of the air inside the laboratory. Therefore, we are just going to use pressure of the laboratory inside to determine the pressure of the vapors. This is important point actually. Volume of this flask will be equal to the volume of the vapors. Next, temperature of the vapors, which is very difficult to measure. As such, therefore, it will be considered as equal to the temperature of the water bath, right? During the experiment, right? While it is boiling. So that is considered is equal to the temperature of the vapors. So these are the points which are very important. N is the number of moles, as you know, and this is equal to weight upon molecular weight. So if we are just going to have the weight of the vapors as we determined in previous slide, we can put all these values here and we get this molecular weight of the vapors or the volatile liquid from which these vapors are formed. So here this formula will be converted into this form. PV is equal to, instead of N, we are just going to put weight upon molecular weight into RT. This can also be written in this form: molecular weight is equal to WRT upon PV. The next important thing is that a student find it difficult to calculate the molecular weight, because here the tricky point is that we are having the units of the pressure, volume, temperature and weight as pressure is measured in atmospheric pressure or it is determined in mmHg in the barometer, right? The second thing is volume can be determined ml, liter, cc, whatever it is. Temperature is determined degree centigrade. Since this gas constant is given in kelvins, therefore we need to convert it into kelvins. Weight we have in grams, right? Now putting all these values here, so we are having the gas constant value as 0.0821 liter atmospheric per Kelvin per mole. So if I am just going to measure my sample in ml and the pressure in mmHg, then I need to put all these values here just to convert this. So in this manner, we are going to get this value for the gas constant. If you are going to measure in liter atmosphere per Kelvin per mole, then you can use this. If you are measuring in ml atmosphere per Kelvin per mole, then you can use 82.1 ml atmosphere per Kelvin per mole. So whatever it is, you accordingly change your gas constant, right? So molecular unit of the molecular weight, we are putting all the values here so that vapors of the. Now the final formula is this. Now we are going to perform the lab activity to get the values of this pressure, volume and temperature and W, right? And then we are going to put all these values here. So lab activity. Right? Now we are going to take this conical flask. We are wrap it with the help of this aluminium foil, and I will make a small hole in this aluminium foil so that vapors get equilibrate with the atmospheric pressure. Now the problem with this is that I am having the beaker is very is small, and therefore this conical flask will not be heated in the water bath. Now instead of this conical flask I am using this density bottle which is having this hole in it lid. Here you can see the capillary through which excess vapors of the solvent will be coming out. Now I will use this, and the weight of this density bottle is 19.5. Right. Now I am going to add the 5 ml of the solvent, which the solvent which I have used here is N-hexane. Here you can see the volume of this. But here I am just going to tell you that if you are having a smaller capacity container, then you use small solvent. Here is the N-hexane. And now I am going to add this N-hexane 5 ml to this density bottle. Right. And it will be my advice that you use bigger container for this purpose. That will be helpful, and the solvent will not get bumped outside this. Now I'll just heat it with the preheated water. Here is the water which I have already heated. Now I'm going to show you the temperature of the boiling water. This temperature we are going to use for calculation part. This will be considered as the temperature of the vapors, right? Since vapors are dipped inside this, therefore, so it is 100 degrees centigrades, and now we are going to evaporate our solvent. You do this carefully so that the solvent will not get bumped outside. Now, once it is completely evaporated, you continue your heating so that every part of the solvent will get converted into the vapors. Now, once it is completely evaporated, as you can see here, nothing is there. So I'm just going to condense the vapors here. Once it is condensed, I will clean it thoroughly so that here you can see. So I clean it thoroughly with the help of the wiper, and now I'm going to weigh this. The weight is 19.583, and now we are going to measure the volume. So here I fill it completely with the water, distilled water, and now I clean it thoroughly with the help of the tissue paper, and now I am going to weigh this. So volume can be determined by two ways, by weighing or density. Mass divided by density, you will get the volume. So its weight is 48.736, and I'm just going to add, this is mass is equal to volume into density, and here we are just going to have this mass. Here is the weight of the density bottle plus water, and now we subtract out of this the weight of the empty bottle, and now we get 30.2. So this is in grams weight. Now we are going to divide it with the density of the water, and density of the water can be taken from the literature at the given room temperature. In that way we can calculate the volume. The second method through which you can directly calculate the volume, you transfer it into the graduated measuring cylinder, and here you can see 30 ml is this. So in both the ways we get the same result, that is 30 ml. here. Now we are going to put. So from the lab activity, we are having this pressure is 754 mmHg, volume of the flask is 30 ml, temperature is 373.1 Kelvin, weight of the vapors is, this is weight of the condensate with the flask, in the flask, and this is empty flask. Now on subtracting these two, we get 0.084 grams. Now putting all these values in the formula, we get finally this much, which is very close to the molecular weight of N-hexane, the sample which we have taken. So I would suggest you repeat the experiment 3 times. So I hope you find this video helpful. If you find this video helpful, please like, share and subscribe. Thank you all. Thanks for watching.